Hey, what's going on, folks? It's Mike here, and today a little bit something different here as we talk about C++. And today's topic is going to be about sorting here. So if you haven't seen this fun video, go ahead and check it out. It's quick sort with a Hungarian folk dance here, and there's lots of other cool animations like this. But with that said, we're going to go ahead and pick up where we left off, talking about the C++ standard template library, and specifically the algorithms library, and as you guessed, some of the sorting functionality. So the sorting library is actually quite rich, and there's many different things that we can do with it. So let's just go ahead and start with the basics and go ahead and dive in with talking about sort and stable sort. So with that said, let's go ahead to our favorite website here, Cpp reference, and in the algorithms library, let's go ahead and take a look here. So I'm going to go ahead and scroll us down. And if you've been subscribed and watching these, again, we've seen many of these algorithms so far. Most recently, talking about many of the partitioning operations that are available, and we're just going to continue on our journey down into the sorting operations. So fundamentally, we're just going to go ahead and start with sort here, and then also stable sort, which preserves the ordering between elements. So that's the difference here, where sort doesn't necessarily have to. So we'll look at both of these and just explore a little bit. But let's just go ahead and start with sort here. So I'm going to go ahead and zoom in here. And let's go ahead and we're going to ignore the until C++20 ones and see that again with C++20, which is probably the version you want to be using if you can choose, we get a lot of const expr support here. I mean, we can do things at compile time. So that's great here. And the other thing that you're going to notice here for sort is, well, we basically just take in two iterators here. And you'll notice that they are random iterators here. So we'll actually try that out with a collection, just again, to remind you what types of data structures have random access. But again, that's something you want to consider or keep in mind as far as if you want to be able to use these built-in algorithms for your particular containers that you might create outside of the regular C++ ones. Alrighty, so anyways, the default behavior is to sort our elements in non-descending order. The order of equal elements is not guaranteed to be preserved, and that's for sort here. We'll look at the stable sort, which does preserve the ordering of equal elements. Again, that might be important if there's some sort of insertion order guarantee, or you otherwise need some sort of ordering of elements that are coming in here. Okay, like if you have transactions and you want to sort of fairly process them, for instance. So that's the idea here. Now the sequence is sorted with respect to the comparator comp here for any iterator pointing to the sequence and any non-negative integer, etc., etc., as long as we're pointing to a valid iterator in the sequence. Okay, so basically we're just walking through our data structure here, or performing whatever algorithm we need. We'll get to the complexity, so you can have your complexity guarantees there within this range here, and performing the sort here. So from the first to the last element here. Okay, and we can provide optionally a comparator here when we have a custom data type, which we will look at in this video here. Okay, so as far as the comparison here, this is the signature of the comparison function that we need to provide here. So for whatever our type is, you can call that function whatever you want here, but we need to take in a left side and a right side, and then have some way to return, well, is one side greater than or less than the other. Okay, and where am I reading that? If the first argument is less than, so it's order before the second. Okay, that's the type of sorting that we're going to do here. Let me see if they provide a default here. They might provide like less or something by default, but that's the idea here. Now the complexity of this algorithm that's built in is nlogn. So we'll see if we get some hints here as to far as what the implementation is, but these could be things like, you know, your quick sort can be O of nlogn. Actually, quick sort, I suppose, could be n squared in the worst case, but merge sort, for instance, has a guarantee to be nlogn. Heap sort could be nlogn. And we actually will look at some of the heap operations available in the standard template library later. So again, make sure you're subscribed for that, or look at that later on in the playlist as those videos come here. But that's the idea here. So there are some notes here that the previous implementations might have allowed here quicksort, which was, as I mentioned, n squared here. And it looks like there is introsort, which can handle all cases with nlogn comparisons, again, without any overhead in the average case here. Okay, so you can take a look at introsort here. Again, it's sort of just one of these hybrid sorting algorithms, and it's kind of neat here. It starts with quicksort and switches to heap sort. So another nice one to add to your arsenal, or just to think about when you get into algorithms. There's also like timsort, which is kind of a famous one that does I think it's merge sort, and then as the arrays get small enough, I think it does insertion sort. So again, some cool stuff that you can think about here and expand not only your data structures, but your algorithms knowledge here anyways. So anyways, let's look at an example here. I think we'll go ahead and write one here. It doesn't provide, I guess we could look at the actual implementations here. Let's actually take a peek here. Let's look at lib standard C++ here. Let's see if it gives us a decent, where is it hopping us here to? Let's see if we get a better look here and try to find sort here. Can we find it here? Okay, we're gonna find a bunch of functions for sorting here. Here's a stable sort. Okay, a little bit unreadable here. So yeah, we're probably not gonna want to look at this too much here. Okay, so we're just gonna take it for what they give us here. That there are nice maybe intro sort or other nlogn data structures here. You could do this with a heap sort, for instance. But again, pretty nice data structure here. Just take in your begin and your end iterators here, and well, that's pretty much it. And as mentioned, we have some of these built-in comparators here, like greater and less. Let's actually play around with those because we haven't messed around with those too much, and then we'll go ahead and look at some custom types and so on. So first and foremost, let's give ourselves a little bit of a data structure here. And I want to actually play around with this just a little bit here, just to show you the different types to make that a point of what we can and cannot use here. So I'm going to use a alias template. I've kind of liked this for being able to replace data structures. I've shown you how to using like my type previously, but let's just start off with a vector here of some type here. Now what's kind of cool about this is I can just do my type and then int here. T, which is, what this value is here is the integer. That's just creating a standard vector here. So I just want to show you some new stuff and stuff that we have looked at. That's the equivalent of what this is right now. Okay. So my type, I'm just going to call it C for container, and we can initialize it with some random, unsorted values. We should put in some maybe negative values here. Make it up 100, 500, give yourself a range of stuff. That's kind of interesting. But anyways, that's the goal here. And we are going to want to use C++20 here. And make sure that we put our semicolons in the right spot. There we go. But that's the idea here. Okay, so give yourself a little bit of data here. And then let's go ahead and just print this out because we're going to want to look at things sorted and unsorted. I'm going to use a range-based for loop for this. Let's just do auto element here. And the collection, these are just integers right now, so I don't really care how I print them out or how efficient. And let's just do some spaces here. And the element. And an end line here. Okay. And do cout. There we go. Okay, so let's just make sure that we get the same thing printed out here if we run it, and we do. Okay, so nothing there too crazy, and let's actually sort it. Let's sort our data. I'll actually do standard sort here, and C begin, C end. Now, when I'm doing this sort of thing here with my type that I might be replacing, again, in previous videos, I've told you, if I know this is a vector, I prefer the member function. So I might actually do something like, use the more generic begin and end free functions for this. I'll have to check if all of the classes have their begin and end. I think most all of them do. But anyways, that's just a little bit more generic for us. And let's go ahead and do this. And, well, just like that, -100, -7, this looks like it's sorted to me. So simple as that. You don't have to necessarily write a sort algorithm when you can just grab one off the shelf. Of course, you want to know your sorting algorithms because they're great exercises. Now, we saw this little standard grader and then treating things as an integer. So let's go ahead and take a look at that. Grader int. And let's go ahead and see what happens here. So that is a... if we go ahead and look at this, a function object, so a functor that will do the comparison, right? It's going to take in the type here and, for these primitive types, just be able to do a greater than or less than comparison. Now, if you also implement your own data type here and you provide it, that could be a quick way to sort of flip things around here. So maybe we'll want to take a look at that here. Okay, so let's go ahead and compile that. And now this time when I run it, we have the greatest element first here. Okay, so nice and simple there. Okay. Okay, so, if you want to mess around with this, and the purpose of me adding this template here, let's go ahead and just try here with a list. Okay, so I'll go ahead and try to recompile this. Let's give ourselves a little bit of room here. There we go, recompile. And, well, we get a bunch of error messages. Why? Well, we sort of have to remember, if you've been following this series for lists, and let's go back here to sort and to the top here, right? We need something that has random access here. Okay. Now, does this mean we're sort of out of luck here? Okay, let's see if we're out of luck here. We don't necessarily want to give up here. Let's go to our list container here. And, well, let's just do Control F for sort, and in fact, we do have a sort member function here. Okay, so the folks who made the standard library didn't just say, hey, it doesn't have a random access iterator, you can never sort lists. No, it's just a member operation here. Okay, so something to keep in mind here. Common operations like this, again, this is sort of the most generic sort that you could have with random access, but a special implementation that handles node-based data structures is provided. Okay, so no problems there. Okay, so let's go ahead and revert that here. And let's just make a note of that as well, just for the comments. Note, standard list has a member function for sorting. Okay, so you're not totally out of luck in that sense. Okay, let's go ahead now and try to sort something else. I like to use the example of like a student, for instance, and they might have an age and an ID. Those could be two different fields here. So let's go ahead and see what happens if we try to now sort a collection of students here. Okay, and we might have to change a little bit how we set up this collection. Let's just go ahead and comment that out for now. And let's go ahead and say we have my type of, whoever our student is. I'm going to get rid of this comparison here. And let's just go ahead and push back. Let's go ahead and actually we can do ahead and in place back, so we could construct in place here a student, age 7, ID is, something like that. Okay. So let's just comment that out and see what happens. And we want to print out all of our students. Well, we have to decide here. Do we want to sort them by their age or their ID? Or maybe some combination of both, right? It's going to be up to us here. Let's just sort them by their ID for now. Okay. That'll probably make sense here. So let's see if this just prints out here. Oops, what have I done here? Missing a semicolon. There we go. And let's just go ahead and run every time we compile successfully. There we go. Okay, so we've got our one student constructed. In place back, constructs them without having to do the copy, so it's like a pushback here. This is going to be my quick way to just create a bunch of students with, different IDs here. Let's maybe have this student here, 1991. These are young students, I guess, here. Let's make them, all sorts of ages. There we go. 16. 19, and they've all probably got to have unique IDs here. So let's go ahead and set that up here. Although we'll see what happens. Maybe let's have a few with the same ID here, and then we'll see what their ages are, and just give them some different ages. Yeah, let's make this one like 2000. I don't know what kind of ID system this is, but interesting enough. Okay, okay, let's go ahead and see now what happens. Let's just make sure that they're printing out. Okay, so we got some folks printing out, but they're printing out in order based off of, well, the insertion order here, right? We haven't done any sorting. So let's go ahead and let's try to sort this container. Okay, just using the default here. Let's see, is our compiler smart enough to give us something that works? No, right? This is gonna totally collapse. It's telling us, right, we need some different operators here. Okay, we could do something with a spaceship operator. Maybe I'll have to talk about that later. But basically say no match for the operator less than here. Okay, so we got to figure this out. Okay, so let's go back to CPP reference to sort here. And again, it told us that we need this here, okay, for our comparison. So let's go ahead and write that. We can write that as a free function. It could be part of the actual structure if we want, but let's just go ahead and paste that in here. And let's go ahead and see. I mean, if we don't write it as a free function, right, think about how we do this, right? We have a comparator here. Let's see if it gave us a hint here. No, we could just use this. Let's just go ahead with what we've been given here. And then our type, student, and we're passing them by const reference because we don't want to make a copy of these things. We just want to be able to compare them. I say we do the ID here, and we're doing A, which is the left side, less than the right side here. Okay, and just comparing their IDs. Okay, so again, I've written this. I can compile it. Still not smart enough to find it, right? We need to provide that ourselves here in our sorting function here. Okay, compare or CMP here. So let's go ahead and get that all on the screen. And now if I compile it, it works. Okay. And let's go ahead and just so you can see everything at once here, something like that. We can see our whole program here. Okay, so here's our custom data structure here, student. We're sorting based off of, well, let's see here. The IDs here. Oh, I guess that's the first field. I mixed those up here. So easy to see how there could be a mistake here. So now let's go ahead and print it out here. And we'll see the IDs. Let's see, 1991. Okay, that is our 16-year-old student. 1996. That's one of these. Oh, we got two 19-year-olds, so we don't exactly know. Let's see if we give ourselves a 20-year-old first. Okay, something like that. Yeah, it still doesn't matter because we're just printing this out. Then we got student ID 20,000 and then 100,001. Okay, so we sort of get the point here, and that's how we can sort our students here. Okay, now let's see here what we want to do to make this interesting or anything more interesting with our sort. Let's just go ahead and put the ID and the age. I'll go ahead and just put a bar here. Element.age. And these could be a little bit hard to see, so let's go ahead and give ourselves an end line between them. But there we go here. Okay, so sorted by their IDs and then their ages here. Now let's go ahead and see. I mean, it might happen to be that this one where we've got the duplicate ID that we're sorting by, that let's see if they get flipped if I flip these values. Again, it just kind of depends on the sorting algorithm here, or if they're preserved here. Let's see here. So again, our IDs are the same. The age is 16, 20. Yeah, I guess it didn't really make a difference here. But that's where stable sort comes into play, as I mentioned here. I think if we had a bigger collection of data, right, this might make more sense here. But again, just a drop in a drop-in replacement here. And that basically just guarantees that, yeah, if we're sorting by the IDs here, and we've got duplicates here. So at the end here, right, these two students happen to have the same ID, whatever, maybe they're twins or something. But, the 19 person should always become before the 20. Okay, so that's what this is showing here, which is not the case in some of our other orders, right? I guess it happened to be in these previous cases that it worked out. But in this case, this one, if it always shows before this one, that order will be preserved. Okay, so it is a stable sorting algorithm. So you can read a little bit more about those or look at them in your algorithms class to see what preserves ordering. Again, sometimes that's important. Again, maybe these aren't students. Maybe these are like orders to some company that ships goods or something, and maybe they happen to have the same ID or price or however you're sorting them by, but you still want to honor like something. Or maybe if the orders are actually placed at the exact timestamp that's the same, you still want to have some fair way to order them. So anyways, that's the idea with sorting, folks. I hope you go ahead and enjoy that. Try that out. Try that out with some custom data types. Write your own comparator here. Go ahead and just flip through the code one more time. So you can go ahead and see that we played around with our custom data types. We went ahead and showed that we can use sort with random access or containers that have random iterators. List, of course, has its own implementation of sort, so you can still use those. I think any other container otherwise that doesn't have random access iterators will otherwise allow you to access or use a member function to do the sorting. And let's see what else here. We did this little trick, not necessary, but just a nice thing to show you as we recall some of our old stuff that we've been learning in this series. And that's it. That's it for us for sorting. Okay, so you can go ahead and check this out or more videos from courses.msha.io. And as always, folks, if you're enjoying this, you now know about sorting and all those fun algorithms that maybe you spent time in an algorithms class. You can just rely on the sort, stable sort, and go ahead and check out some of the things like introsort as well. I thought those were neat things to know about, that these things exist right beyond what most classrooms might teach you. Anyways, folks, with that said, thanks for your time and attention, and I'll look forward to seeing you in the next one.